Hello, students. You're welcome today. We have a very fresh topic to work on. Introduction to salt, number one. This is the very first video for this very topic. Okay, before we talk about salt in detail or the definition of salt, first, there is something you must have to know. Concepts of salt you need to understand. Number one is rational number, and the next is irrational number. What is a rational number? A rational number is a number that can be expressed as a ratio of two integers. Now, how do I mean? These two integers are, let's say, a over b, where b must not be equals to 0. Okay, so here, because if b is 0, b can be anything. Like, let me say this a over b can be like 2 over 5, 7 over 6, but what we are saying that it cannot be 0 is where 5 and 6 are representing b, 2 and 7 is representing a. But if I have it as 7 over 0, that's what I'm saying, this automatically become undefined. So this thing, the value of b here cannot be 0. If I have 2 over 0, it will also be undefined. So we are trying to say you should avoid anything whose denominator will lead you to 0. But denominator can be 1, can be 2, can be 3, can be any number. Okay, so that's it. Now, when we talk about integer, an integer is just a set of negative and positive numbers where you have -1, -3, 5, 7, both positive and negative. Now, the next thing I said you need to know is irrational numbers. What's an irrational number? An irrational number is a real number that is not expressed as a fraction. It's a real number that's not expressed as a fraction. Now, how do I mean? Example of a real number is square root of 2, square root of 5, pi, and the rest of them. So all these things are square roots, are irrational numbers. They can keep reoccurring. You see, if you take what is the value of pi, you can get that 3.1427 continuously, and it will continue. 3.142 will come again. So this number will keep reoccurring. So these numbers are called irrational numbers. Now, having said this, what is then a surd? A surd is an irrational number expressed in the form of roots, in root form. For instance, root 2, root 3, roots, anything that is surd. Okay. Now, having said this, what will be the rules? There are rules for surd. There are rules, basic rules for surd. Number one is, let me say, square root of x, y, which is multiplication. Now we give us square root of x multiplied by square root of y. What about square root of, number two, square root of x divided by square root of y? What will it give us? Square root of x over y. Then, but square root of x plus y will not give us square root of x plus square root of y. Please take note. Then for square root of x minus y will not also give us square root of x minus square root of y. Okay. Now, these are the rules we'll be using we'll be applying in solving surd in detail. But before we enter into that, there is something I want you to understand before we dive into surd properly. Maybe this might have been several times, as in you've studied surd as a topic severally, and maybe you don't understand it. There's something you might have not known. And what is that? That is what is called a perfect square. A perfect square is a fundamental aspect that must be understood by anyone who wants to understand surd first. Now, what is a perfect square? It's actually very simple. A perfect square is a product of two same numbers. That's just it. product of two same number. You know, product is a number, a value obtained after multiplication. So if I say 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is what? 16, 8 times 8, 64. Let me stop here. All these values are called perfect square. Why? Because two same numbers, 2, 2, 3, 3, 4, 4, 8, 8, two same numbers multiply themselves to give us this. Okay? That is why you can possibly call them a perfect square. Now, what about if I have 3 times 2, give me 6. 8 times 5, give me 40. 7 times 9, give me 63. All these numbers, what are they? They are non-perfect squares. Why? Because 3 and 2 are not same. 8 and 5 is not same. 9 and 7 not same. Now, that even quickly reminds me that in one of these days, people keep on saying men are not perfect. You know, men are not perfect. Sometimes I try to analyze it, and mathematically, I have come to confirm that indeed, with what we've done or what we are doing now, mathematically, I can attest to the fact that men are not perfect. Why? Men did not belong to this group. Why they belong here? Yeah, you can check it out. 2, 2, give us this. Do you know that you watching me there, or even me particularly, I am a product of fusion of male and female zygotes. Okay, now two different persons comes together to produce me. So I'm a product of two different persons. So if my father met another, maybe his elder brother, and they gave birth to me, maybe I would have been perfect. What am I trying to say is that perfect squares is depending on two same numbers, product of two same numbers. So if you can be able to have this at the back of your mind, I tell you, you'll be able to solve any kind of sort questions. Okay, let us proceed. Let's say we have a question like square root of, what do I use? Let me say 24. They say simplify square root of 24. What should come to your mind based on what we've done here is, what are the two numbers that when I multiply them, they will give me 24? One must be a perfect square. Yes. It's only one of that numbers. If there are two numbers that are perfect squares, no, you are wrong. Okay. For instance, I say 4 times 4. Okay. They will give me 64. So 4 times 4 is 16. You know, I don't need this. Because these two things are perfect squares. We are looking for two numbers that not two of them should be a perfect square, and not two of them should be non-perfect square. It's just only one we need. One will be a perfect square, the other one will be a non-perfect square. So now, how do we get this? Somebody very smart will say, okay, 4 times 6 is 24. That's correct. But what about somebody who may struggle to understand that the answer is what you need, the two numbers at 4 times 6. So how do we give to them so that they will be able to cope up with you? So I come up with this method. We have 24. Find the factors of this. 2. 2 here is what? 12. 2 here will give us also what? 6. 2 here will give us 3. And 3 here will give us 1. So can we check? What do we have now? We have 2 times 2 times 2 times 3. Now, 2 times 3 is 6. 2 times 2 is 4. Do you now see? This is how he arrived. The person may arrive at 2 times 4 times this. So we can get now that square root of 24 is equals to the same thing as square root of 4 times 6. Okay? Haven't done this. The next thing, remember, if you've gotten this, which is in form of this, you have to simplify it in this manner, which means square root of 4 times square root of 6. Okay? Square root of 4 becomes 2, and square root of 6 is a irrational number. So because of that, we leave it as 6. This is an irrational number, so we leave it this way. I hope that is very clear. So if I give you, what if I give you square root of 50 plus square root of 32. Okay, if I have this solution, what do we do? Please, if instead this thing will stress you, use the same pattern I use. 50 by 2 will give me 25. By 5 will give me 5, and 5 again will give me the 1, which means 5 times 5 is 25, which is a perfect square. 2 is not a perfect square. I'm going to have square root of 25 times 2. Okay, plus 32. What do we do to get 32? Okay, in 32, we are going to have 2 here is 16, 2 here is 8, 2 here is 4, 2 here is 2, and 2 here is 1. Please, when you do this, how can we arrange it to give us, we have 1, 2, 4, times this, even 16. 1, 2, 3, 4. 2 times 2, 4, times 2, 8, times 2, 16, and 2. You can use square root of 16 times 2. So, can we split it the same way we did this? We have square root of 25 plus square root of 2 plus, times square root of 2 plus square root of 16 times square root of 2. Please check this. This is times. This is times. Why this is addition or plus? Now, square root of 25 is 5. Then root 2 plus square root of 16 is 4 root 2. What did you observe now? This is 2. This is 2. Okay, so this is 2, this is 2. So can you factor out anything? There is no factor here apart from this. So you can say it is okay, since they have the same, good, since they are of the same roots, good, you can add the two sorts, which means it can be root 2 open bracket 4 plus 5. I don't know if you get it. Remember, there, if you factor out this, if you say this times this, it will give you this. This times this, so it is a factor of that. This plus this is what? 9. So we can have it as 9 root 2. Okay, please, this is a simple solution to this very question. It is very, very simple. Okay, if there is anything you don't get very, very clear, please do well to ask your question. And I will not hesitate to come to the comment section to attempt to them. Please like this video and share it. Okay, that is the only way you can support us. Thank you and have a very blessed time. This is an introduction. The other series, continuation of this, will come your way soon. Thank you.